guys, and welcome back to another class of our course about the complete introduction to quantum computing. So in today's class, we are going to talk more in depth about the subject and basically understanding what exactly is quantum computing. So by the end of the class, you will be able to understand in general what exactly is quantum computing, what's the main difference between classical computers and quantum computers as well, in what areas are they really useful, and finally, do they exist or not yet? So not wait anymore and let's jump right into it. Alright, so the first question that everybody's asking itself, what exactly is quantum computing and how exactly they work? So basically quantum computers are, well, the main definition of what exactly this is will be the quantum computers are an area of computing that is focused on developing computer technologies based on the principle of quantum theories. So when we say quantum theories, we can think about different algorithms, we can think about different theories around quantum physics as well as quantum mechanics. Which explain the behavior of energy and material on the atomic and subatomic level. So it's really more advanced than basic computation. And so the next thing would be what is the difference between those computers and normal computers? Well, basically, classical computers will work with ones and zeros, so basically with bits. But in quantum computing, it's a bit more different because you guys work with qubits. So basically, what's the difference between a bit and a qubit? So a bit could be 1 or 0, but a qubit is a bit more advanced. Well, it could be both at the same time because of the property of superposition. Once again, this is a property of quantum computing, and we're gonna talk about it a bit later, well, in another class. But just for you guys, just for your information, and for you to know that superposition is one of the properties of quantum computing. So basically, this is a completely different kind of computing because right now, with operations that can take years to a normal or classic computer to resolve, in quantum computing, it can be resolved in seconds. So basically, when I'm saying that it's a different kind of computing, it is really a different kind of computing. Because as I said, classical computers, they manipulate ones and zeros. And well, because of the power of the qubits, or not the power of the qubits, but basically because of what qubits can bring to quantum computing, this allows us to basically make operations, do operations way faster than in classical computing. All right, next thing that we are gonna talk about today would be how quantum computing works. All right, so basically quantum computers or quantum computing works, as I said, with qubits. So basically, quantum bits or qubits, because qubits means quantum bits. So basically it works with bits, but they're just quantum. So as I said, those can be 1 and 0 at the same time because of the property of superposition, and this would give the quantum computer its higher power at if we compare it to a classical computer. So in other words, before we can verify if the qubit is a 1 or a 0, the element can exist in a quantum superposition. This means you will have the probability of the qubit being a 0 or a 1, and it's possible to calculate this property using mathematical formulas. Basically, to be able to verify if it's a 0 or a 1. So to give you an example, let's imagine that we have 2 bytes or 2 bits. So basically the 2 bits, as I said, could be 0 or 1. So what can happen? So you have 4 possible operations that can appear with those 2 bits, and basically the operations would be 0 0 0 1 1 0 or 1 1. So basically if we say that each of those bits is n, so basically it's an n value, this means that our computer is able to work with n values at the same time. So basically with 2 values in the case that we have 2 bits, so each bit is 1n. So it can work with n value, it could work just with 2 values. But if we do the same operation with a qubit, in this case it's a bit more different because each pair of let's say bits together will be considered as a let's say an element, And basically how it will be calculated, it's gonna be a bit more different. So basically, because of the property of superposition, it's possible to, well, to have one of the 4 operations. In other words, 2 qubits contain 2 at the power of 2, so in our case 4 numbers, and n qubits will contain 2 at the power of n numbers when a classical computer only contains n number or n number of bits. So basically, if for example we have 3 bits, so basically in a classical computer we have 3 bits, with 3 qubits it's possible to perform 8 operations, because we have 2 and it's gonna be at the power of 3. So basically, as you can see, it grows really exponentially, and because of this exponential growth, it's possible to have way more power inside of a quantum computer if you compare it to a classical computer. But it's important also to understand that they're not necessarily better than classical computer. They're just way more powerful in some really specific tasks. So basically, if we have some really specific calculations that we want to perform in today's world, well, they will be basically used for those operations. But we're not yet at an era where we can use it on our everyday life. So basically, it's really for some specific calculations that are really well, it's really specialized in those applications. So basically, if quantum computing becomes a bit more popular and we develop really a lot of quantum computers, in what field they will be really useful? So basically, they can be useful in plenty of fields, but 4 of the more important, in my opinion, are those right here. So the first one will be cryptography, so everything that is around security and all those things. Let's say, for example, we want to perform a brute force attack. Well, this is in hacking, so we want to perform a brute force attack on a password. What does this mean? It simply means that we will test all the possible combinations of a certain password. Let's say it's a password that has 2 characters. So basically, there is 99 possible combinations if we only have numbers inside of this password. So if, well, with a normal computer, this type of operation will take, let's say, a few seconds. Now, let's say instead of 2 elements, we have 3 elements and they're numbers. So once again, right now we'll have almost 1,000 different combinations. So once again, it's gonna take more time to our classical computer. But let's say, for example, we have 20 numbers inside of our password, and there are not only numbers, but also letters and special characters. Well, in this case, it's gonna take hundreds of years to our computer, to our classical computer, to be able to crack down the password in question. And basically, this is not efficient. With quantum computing, well, if you guys want to perform this type of attack, it's gonna take seconds. So it can work this way, but if we reverse engineer, it's possible also to find the combinations that will work against all this. So basically, to make systems way more secure, to create, as I said, a way more important securities around, let's say, bank accounts, around credit cards, around plenty of things. Because once again, with the power of quantum computing, it's possible to do so. It can be really useful for artificial intelligence, because once again, artificial intelligence, it's a huge part of the future. And once again, artificial intelligence requires a lot of calculations. So it could be hundreds of thousands of calculations per second. Well, depending of how advanced we want it to be, or how advanced we want artificial intelligence to be. And basically, to be able to perform all those calculations at the same time, yes, it could work with a classical computer, but it will require a lot of computing power. And if you don't have a lot of computing power, well, the thing is, it's not gonna take seconds, it's gonna take minutes and even hours. With quantum computers, it's possible to perform all those operations in a fraction of a second. So basically, everything will become way more faster, especially in the field of artificial intelligence. When I'm talking, the next thing would be finances. So when I'm talking about finances right now, it could be, for example, for trading. So in the trading industry, there is a lot of people who are performing technical trades. So basically, they are working not only with the systems or indicators and this type of things, but really more advanced mathematical trading. So really based on different algorithms, really based on different mathematical concepts. And sometimes it's not really easy to to create a strategy and to backtest it on, let's say, 20 or 25 years on a second graph. So it requires a lot of calculations. So with quantum computing, it will be possible to test really advanced strategies, well, more advanced strategies that we have right now, and really create, well, a revolution in the financial industry because of a new type of trading that has, well, that integrates way more calculations. And with quantum computing power, it's gonna be, well, it's gonna be a revolution. So basically, because of this, the first companies that will have access to those computers will be able to basically, well, will be able to make a lot of profits from those computers. But once again, as I said, they can really be useful for some really specialized tasks. So basically, not because you're having those computers that you will be able to become a successful trader or succeed in the trading industry, but really because you have great engineers behind it, and well, they develop the strategies, and because of all this, they are able to really, well, create great trades with this quantum computer. So these are some examples of where exactly quantum computing could be really interesting. In particle physics as well, but I'm not gonna talk too much in depth about this subject. All right, so finally, do quantum computers currently exist? So this is a great question. So quantum computers are currently, well, they're not existing as we think. So basically, they're not small computers that we can have at home and basically work with them. But in October, well, the 23rd October of 2019, Google was able to perform a calculation. Basically, they worked with a partner. Well, they had a partnership with the NASA, and basically they were able to perform a calculation, a really advanced quantum calculation that usually would take 10,000 years to a normal computer. But with a quantum computer, they were able to perform this calculation in seconds. So as you can see, the difference between the two is really enormous. And this is why quantum computers, in my opinion, are really the future of computing. Well, especially for those really specialized tasks. So I hope right now, guys, you have a little introduction to the subject. So as you can see, the subject is not simple to understand. But once again, this is a really interesting subject, and it's really worth it to have an introduction to it. So that's it for this class, guys, and see you all in our next class.